Today, we are going to find the exact value for sine of 3 degrees, and we'll do everything from scratch, including all the special right triangles and also the angle difference formula that we need. So be sure to check out the whole thing. This is going to be really cool. But before I start, let me first give a shout out to Chester, because he recently did a video on sine of 10 degrees by using complex numbers. It's really cool. Be sure you guys go check out that video if you haven't done so already. And I also want to thank Toby for your t-shirt. Thank you for sending me this t-shirt. This is ketchup, this is a kind bottle, and her channel name is TBs, if you guys don't know it already. I will have the links to their channels in the description. Be sure you guys go check them out. Now, let's talk about sine of 3 degrees. Everybody knows 1 plus 1 plus 1 equals 3, but I know 18 minus 15 is equal to 3. So let's look at sine of 3 degrees as 18 degrees minus 15 degrees. And the reason is because both of the 15 degrees and also the 18 degrees, they are special angles. You'll see why. Anyway, as I promised it, I'll show you guys the proof. So the first thing is that I'll show you guys how to prove a angle difference formula for sine. And this is how we'll do it. We'll use complex number. We'll use Euler's formula. So here is the deal. We are going to look at the following. So consider e to the I times alpha minus beta power like this. First thing first, whenever we have e to the I theta, an angle, we can use the Euler's formula. And Toby has a really nice video on the Euler's formula, so be sure you guys go check that out. Here I'll just use the formula. Well, what this is that we will just get cosine of the angle, which is alpha minus beta, and then we add I times sine of the angle, which is alpha minus beta, like this. Okay, so this is nice. Now we can look at this in the following way. Because of course we can distribute the I, and then because this is exponential, so we can do the following. We can look at this as e to the I times alpha, and then times e raised to the I times negative beta power, like this. When you multiply this, of course you add the exponents, of course you can factor out the I, and you get that. And now you will see, when you look at this, we can apply the Euler's formula for the first part, and then the Euler's formula for the second part. This is very, very nice. So, if you look at this part, we get the following. This is going to give us, well, I'm going to just continue right from here, because otherwise I wouldn't have enough space to do all the work. So, I will probably write it as 1 and 2. So, number 1 is right here, and of course, 1 is equal to 2. I mean, expression 1 is equal to expression 2, okay? Anyway, here's the deal. For this one, Euler's formula in action. We have cosine of the angle, which is alpha, and because I only have one angle inside, I will just write it as cosine alpha without the parentheses. It's easier this way. And then we add I times sine of alpha. That's nice. So that's that. Now, for this one, we'll multiply. We have the angle being negative beta, so here we have cosine of negative beta, and then we add I times sine of negative beta, like this. And this is also very nice. Now, we can simplify this a little bit. Here, this is equal to cosine alpha plus I sine alpha. And then this right here, because cosine is an even function, so cosine negative beta is the same as cosine beta. So this is cosine beta, and now I don't need to put down the parentheses because I only have one thing. But sine is an odd function. It's okay though. That means we can just put a negative in the front. So we have minus, and then we have the I times sine beta. And because now I just have beta, I'm not going to put down parentheses. Otherwise, I'll go crazy. So this is what we have. And now if you would like, of course, you can continue to multiply this out. And that's actually the strategy. Well, keep in mind, what we are trying to do is we're trying to get a formula for sine of an angle minus the other, which is right here, isn't it? Well, look at this expression. We have a real part and also the imaginary part. And we know 1 is equal to 2. So if we can get the imaginary part from expression 2. That means that has to be the same as that. That's so nice. So here is the deal. I'm just going to multiply out everything real quick. So this times this is cosine alpha times cosine beta. And then this times that is minus, let's put the I first. We have I, and let's write down the sine first. So we have sine beta, and then cosine alpha. And then we will have this times that. I will put it down here, which is plus I sine alpha, and then cosine beta. And then this times that. Negative times a positive is negative, and then I times I is I squared. And then this times that is just sine alpha times sine beta. So this is what we have. Well, from here, as you can see, this right here is a real part because it doesn't have the I. This right here, it's also the real part because I squared is the same as -1. So this is just as real as we are. But this and that, they both have the I. Well, the imaginary part on the left-hand side has to be the same as the imaginary part on this side, right? So they are technically equal. 1 is equal to 2, as I said. Oh, by the way, I forgot to put down 2 right here. There we go. All right, so now we know that this has to be the same as that. We ignore the I, right? Because we're just looking for the part. So therefore, I'll just put down, so we know that sine of alpha minus beta. Let me just put this down right here for you guys. And yes, you guys can do the same for cosine, but I just care about the sine right here. Sine of alpha minus beta is equal to this and that, but let's put on the positive first, which is this part. This is equal to sine alpha times cosine beta. And then we subtract sine beta times cosine alpha. So sine beta and then cosine alpha, like that. Angle difference formula for sine. Again, you can do the same thing with cosine, but you have to pick up the real part from this right here. Okay, so now that's pretty nice. Well, we continue. This right here is nicely equal to sine of 18 degrees. So let's just put that down because that's the first angle, 18 degrees. And then we multiply by cosine of 15 degrees. So cosine of 15 degrees right here, and then minus sine of the second angle, which is 15 degrees. And then we have cosine of the first angle, which is 18 degrees. So let's just write it down right here. Yes, what in the world is sine 18 degrees and also cosine 18 degrees, right? So now let's talk about the special triangle. This is done, so that's nice. Okay, so let's put this down right here. Let's see if we can fit everything right here. I don't know, but we'll try. This is how you generate, this is how you construct, this is how you come up with the 18, 72, 90 special right triangle. But I don't want the angle to be 18 yet, so this is what we do. So you first draw an isosceles triangle, and because you're constructing the right the triangle, you can just say the sides are 1 and 1 right here, right? Because you're just constructing the triangle from scratch. And you want this angle to be 36 degrees. Again, no 18 yet. If this is 36 and this is isosceles, then we know these two angles will be the same for the base, right? The base angles. And of course, 180 minus 36 and divided by 2, you know that these two angles will be 72 degrees and also 72 degrees. That's very nice. Well, you guys should know what we'll do next. If we can figure out this side, cut it in half, then we can get the special right triangle, isn't it? But I don't know what this is yet. But the best strategy when we encounter something that we don't know is just that we can call this to be x. How's that? Very nice, huh? Now, check this out. Well, this right here is x. What we'll do is, I will just kind of rotate 36 degrees. So I will actually cut this in half. Because this is 72 degrees, and if you rotate 36 degrees, this is exactly half of that angle. So we're angle bisecting, right? Well, this right here is 36 degrees. And notice, this is 36, this is 72, that's also 72. And with that said, this right here is x. This right here is also x. Now, here's the deal. If you look at this right here, we have this triangle in black. Let me just try to make it as scale as possible. We have 1, 1, and x. But if you look at this red triangle, okay, we have x and x. So let me just put this down. This is smaller. And notice this is 36. This is also 36, right? So they are similar because all the angles are the same. But this is x, this is x. I need to know what this is. If I can do so, I think I can come up with a really nice similar triangle and can come up with some equation for that, right? Well, check this out. The whole thing is 1. And this is x already. Oh yeah, I got it. This right here is x, right? Well, check this out. This right here is 36 degrees because we said it. This is 36, that was 36. That's how we can make the 72. And now, this right here is x. This is 36, that's also 36. That means we have an isosceles triangle. So if you look at this part, since this red part is x, and this is isosceles, that means this right here is also x as well. With that said, because the whole thing was 1, this is x. So this red part is 1 minus x. So I have to think there. And then, of course, you can just put this down right here. 1 minus x for the base. Now, as we talk about it, these two triangles are similar, so we can do the following. So I will just do this. I will say 1 over x is equal to, I'm doing this over that, so I will put this over that. It's equal to x over 1 minus x, like that. And now we have an equation right here. Let's just go ahead and solve this equation real quick. Cross multiply if you would like. We get x squared, that's equal to this times that, which is 1 minus x. And then you put everything on one side. This is x squared plus x minus 1, and that will give us 0. And then, of course, we can solve this by the quadratic formula. So we get x is equal to negative b, which is negative 1, plus, no minus, because if you have a minus, the whole thing would be negative. It wouldn't make sense in a triangle situation. So just the plus version is all we care. And we open a square root. 1 square, right, that's a b square, so we have 1. Minus 4 times this and that, but this is negative, so it becomes plus. So plus 4. So 1 plus 4, right here inside is 5. And divided by 2 times 1, so we have divided by 2. So this is what we have. And yes, this is somewhat related to the golden ratio, isn't it? But anyway, check this out. What we are saying is that x is equal to this number. So let me just come back right here for you guys. X is equal to, depends on how you want to write it. Let me just write it as negative 1 plus square root of 5 over 2, like that. Well, if you would like, of course, you can look at this. And what we do is, of course, you just cut this into half, like that. So all in all, we can come up with the special right triangle that we need. So of course, this is a right angle. Originally it was 36. We cut in half, so this right here is 18, right? So I will just tell you guys, we have this right here. Okay, so non-drawn to scale, okay? So this is 18 degrees. Okay? the side is 1. Well, we cut in half, so just put another 2 in the denominator. 2 times 2 is 4 in the denominator. So here we have negative 1 plus square root of 5 over half of that, so we have the divided by 4 like this. Based on this, we can figure out sine of 18 degrees because sine is the opposite over hypotenuse. So it's just this number pretty much. So we get this right here. But we don't know what cosine is. We need the adjacent side. So let's see if we can come up with the adjacent side right here. And to do so, we'll just use the Pythagorean theorem. But that's a famous one, so I'm not going to prove that. A squared plus b squared is equal to c squared. But I will label this as, let's say, b. So to get this side, what we do is just open the square root. Hypotenuse square, which is 1 square, right? 1 square. And then minus this thing square, right? So let's put it down like this. 1 square minus this side square, which is negative 1 plus square root of 5 over 4, and we are going to square that. This is going to give us that side. And now let's just do the algebra right here real quick. This is square root. This is 1 minus, okay, the bottom here is of course 16. 4 squared is 16. And on the top, let's see. Let me just make the square root slightly bigger. This is a binomial, you square that, so you have the first thing square, which is 1. And then you do 2 times this and that, so it's going to be minus 2 times this and that is just 2 times the square root of 5. And then lastly, you add this thing square. Square root of 5 squared is just a nice 5. And now, of course, we can get some common denominator. We can just put a 16 here and 16 here. And we see this is the square root, everybody over 16, like this, right? On the top, we have 16 minus, be sure we have a parentheses. Now, this is 1 times 16, which is 16. 16 minus 1 is 15. 15 minus 5 is 10. So we have a 10 right here. And then, of course, minus times a minus is a plus. So we have a plus 2 square root of 5, like this. And if you would like, you can just simplify this real quick by 2. Divide this by 2, we get 8. Divide this by 2, we get 5. Divide this by 2, this is just 1. So this side is square root of 5. And yes, we have a square root instead of the square root. It comes up really often when we are doing sine cosine. But anyway, we have this right here, and then divided by 8. And of course, you can simplify that, but let's not worry about that. That's later, okay? So, ladies and gentlemen, here we have a special right triangle for the 72, right? This is the 72 degree. 18 degrees, 72, 90. Special right triangle right here. Whew. Okay. So far, so good, huh? Now, we'll come back here. Okay. But I don't know what cosine and sine 15s are. Okay, don't worry. I have another special triangle for you guys. So, here is the deal. But let's just actually finish everything in the middle. In order for me to come up with the 15 special triangle, we have to do the regular special triangle first. So anyway, this is how we do the special triangles, the normal one, okay? So when you start with a square, this is 1, 1, 1, right? 1, 1, 1, 1, 1. Everybody is 45 degrees. I mean, everybody is 90 degrees. And you just cut this into half. And by Pythagorean theorem, this is the square root of 1 square plus 1 square. So this is very nice. So if you just make the cuts, we get this right here is 45 degrees, 45 degrees. Special right triangle, isn't it? This is 1, this is 1. The diagonal is the square root of 2, which is the hypotenuse. So this is the usual square, this is the usual special right triangle. And if you start with a equilateral triangle, everybody has the same side, everybody have the same angle, so I'll just put on 1. And everybody is 60 degrees inside. And this is much better than that one, because all we have to do is just cut this right in the middle, and in that case, this is 1/2. And we can again use the Pythagorean theorem. We'll see this right here is 1 right here, and then this is 1/2 here. And if you want to figure this out, in fact, the easiest version is you don't start with 1, you start with 2. So I'm sorry, let me just erase this a little bit. Start everything with 2. So we're constructing the triangle, so I can put down, let's say we want each side to be 2. And then we can say this right here will be just 1. So we see that this right here is just 2 and this right here is 1. But we still have to figure out this side, which again, do it the quick way. This right here, let me just indicate that right here, which is the square root of the hypotenuse, which is 2 square, right? And then minus this side square, hypotenuse square, which is 2 square minus 1 square. And this right here is 4 minus 1, which is 3 inside here, right? So we have square root of 3 like that. And this is the 30 because that's half of 60, 30 degrees, and this is still 60. And we have a right angle, so that's a special right triangle. Well, similar, but this is much cooler, but it's of course somewhat difficult as well. This is much easier. Now, 15, 75, 90 special right triangle. This is how you do it. You are going to utilize this and that. Let's start with, well, I will start with a 45, 45 special triangle, okay? But I'm not going to label the sides yet. What I will do is I will just first make a cut right here. We'll draw a line, and then I will draw a 45 degree. And again, we're constructing, so this is okay. Again, this right here is 45 degrees. I'm not going to label any sides yet. Then what I will do is I will put this right here. I just want the 30 degrees to be right here though. So when we do that, I will have 30 degrees here. Okay? And then I'm just going to continue my lines like this. But what I would like to do is I would like to start right here and then make a right angle. So this is a straight line. I can just put a right angle here. Okay? And that's pretty much it. And then I will finish this rectangle. To do so, of course, I will just extend from here to here. And then I will go up right here. And I will complete this rectangle, not complete the square. This is so beautiful because you'll see this is 45, this is 30. And of course, everybody right here add up to be 90 because we have a rectangle. And of course, with that said, this right here will be 15 degrees. You can do this in your head. 90 minus 45 minus 30, you get 15 degrees. So now, we just have to figure out the other sides. And notice what I did earlier. Because we're constructing the triangles on our own, we can label whatever side that we want. But once you put on some numbers, the other numbers have to base on the numbers that you chose, right? This is how I would like to do it. Look at this triangle. This is 30, 90, and this right here is 60, isn't it? I would like to put down the special right triangle right here. So I will label this as 1. And the hypotenuse, which is this right here, I will label that as 2. This is this side. And this right here is square root of 3. So I'll put this down as square root of 3 right here. Okay? So now, here is the deal. This is 45, 45, 90 special right triangle. But we know the hypotenuse in this case is square root of 3. Well, earlier, the hypotenuse should be square root of 2. So how can we fix that? Don't worry. Because all we have to do is multiply by square root of 3 divided by square root of 2. So let's just multiply every side by square root of 3 divided by square root of 2. When we do that, you will see this and that will be cancelling out, and then we have just square root of 3 as the hypotenuse. And we can, of course, kind of scale this up a little bit. This times that is just square root of 3 over square root of 2. Likewise, for this side, square root of 3 over square root of 2. And this is very nice. And that's exactly what we'll do right here. I will label this picture here. This is square root of 3 over square root of 2. Likewise, this is isosceles, so that's very nice. But the deal is that, you see, this is 90, this is 45. and they form a straight line. So the good news is that this right here, it's also 45 degrees. So is this, because again, we have a right triangle. So this right here, it's also 45 degrees. So this is so much easier, so this is so nice. Because in this little right triangle, we had the hypotenuse is equal to 1. Well, this time, what I will do is, I will just divide everybody by square root of 2. So it says that this part is 1 over square root of 2. And this part is also 1 over square root of 2. That's so nice. That's so nice. So nice. Now, here is the deal. Check this out. Yes, we have the 15 degrees here, huh? Check this out. 15 degrees, and this is 90. Well, I need to figure out this side. I can just look at here. Notice, I just had to do this plus that. Thankfully, I didn't rationalize the denominator because they have the same denominator. Well, if you rationalize, you still have the same denominator anyway. Or actually, wait, sorry. This is square root of 3 over square root of 2. Anyway, I'll just do this plus that. For this side, which is square root of 3 plus 1 over square root of 2. And then, for this side, as we can see, the whole thing is supposed to be square root of 3 over square root of 2. We have 1 over square root of 2 right here already. So this right here has to be this minus that, which is square root of 3 minus 1 over square root of 2. And congratulations, we just get our special right triangle for the 15, 75, 90. Special right triangle. Special right triangle. Okay, so we can come back here and do all the things that we need. Sine of 18 degrees. Let's look at this picture, which is this over that. So it's just this, because thankfully this is equal to 1. Therefore, I will just open a parentheses. Sine of 18 degrees, just this, which is, I will put down the square root of 5 first, because this right here has a square root of 3 first. I think I'll just do that. So square root of 5 minus 1, be sure the square root is just for the 5, over 4, right? And over 1 doesn't really matter. So that's sine of 18 degrees. And then cosine of 15 degrees is, look at this picture, we will have to do adjacent over hypotenuse. And don't forget hypotenuse is 2. So we have to put the 2 in the denominator. So we have the numerator being square root of 3 plus 1 over 2, and then there's another square root of 2, right? So 2 square root of 2, like this. So this is very good. And then minus, and sine of 15 degrees, same deal. We do this over that, which is square root of 3 minus 1 over 2 square root of 2. And lastly, cosine of 18 degrees. Cosine of 18 degrees is adjacent from here divided by the hypotenuse, which is just 1, which is just this number. So I will put this down also in blue, why not? This is slightly more bizarre, so I will simplify this in our head. Okay, so let's do this together. On the top, we have square root of 5 plus square root of 5, so that's okay. Yeah? Divided by. Well, let's look at this right here. This is square root of 5 plus square root of 5, but then divided by square root of 8 for that, right? And square root of 8, we know this is the same as square root of 4 times square root of 2. So this is just a 2. And this is another square root of 2. Like this. Oh my god. In the end, let's see if we can simplify this a little bit or not. Not so much though. Let's see. This is 2, this is 8, this is 8, this is square root of 2. What can we do? Nothing too much, huh? So perhaps this is 4 times 2, that's 8. And that's 8, and the square root of 2. Now I should get a 16 somewhere in the denominator. Let's see. Square root of 18 is No, cosine of 18 is square root of. Yes, and then, Oh, I see. Let's just rationalize the denominator. That's nothing too much we can do. So let's just do that. So I want everybody to have these two things to have 16 in the denominator, okay? Because this is 8 square root of 2. So let me just multiply this by square root of 2, and let's also multiply this by square root of 2. With that said, you will see, okay, let's put this down right here. And because this is the final answer, I will just write it big enough for us to see. So 4 times that's 8 times that is 16, so I can have that. And now I'm not going to multiply all the top, so you can do that on your own if you would like. This is square root of 5 minus 1. You can have the square root of 2 somewhere, but you can also distribute it. This is just your preference. Let's just at least multiply this in. How's that? Yeah? So we have square root of 6. And I think this is how Chester has it on your PDF, on his PDF as well. So Chester, this is the form that you have. Right? So distribute the square root of 2, so that's nice. Now, minus in between. But check this out though. Square root of 2 times square root of 2 is 2 times this times that is altogether just an 8. I need to match with 16. So I need to multiply this by 2, this by 2, so I can get the common denominator 16. So be sure we have this 2, so I'll put down the 2 all the way in the front. And then I will just keep this, that's how they are then, I guess. This is square root of 3. And of course, you can distribute the 2 if you would like, but that doesn't really matter. Anyway, we're done though. So minus 1, and this is a bizarre square root of 5 minus square root of 5. So, ladies and gentlemen, sine of 3 degrees is this, right? Square root of 5 minus 1 times square root of 6 plus square root of 2, and then minus 2 times square root of 3 minus 1 times square root of 5 plus square root of 5, all over 16, right? Wow, I'm fitting everything on this board. I'm so happy about it. Now, this is so satisfying. But anyway, this is it. Thank you guys so much for watching. I should prep more to organize the board before I do this, but this is so cool. Anyway, if you guys like the video, please give me a like, and again, please check out Chester and also Toby's. Check out their channels, right? Links will be in the description for you guys. And as always, that's it. And Catch Up says bye too. Bye.